Hey guys, it's been a while because I'm busy, but I thought that since now I'm on spring break, I would make another tutorial. So that's great news because this channel is sort of inactive for most of the year, but March is the time when I actually get around to doing stuff. So today's tutorial comes from a request from this guy, and he was wondering basically how do you make a touch input control scheme for mobile devices in GameMaker Studio. So let's get right into it. I've got here a sort of a project I've put together, a little dummy game controlled with the arrow keys. About a little mustache guy, he runs around, does stuff, and he dies. So it's a really simple game, made in about an hour. All it uses are the arrow keys, the 4 arrow keys. So the input method we're going to look at today is basically just making buttons on screen with GameMaker that emulate arrow key presses. And these things are called virtual keys. So let's get right into it. So this you don't really have to worry about. The game stuff, that's sort of irrelevant. What we want to focus on is this thing, the object control, because that's where we're going to be handling all of the virtual key initialization and stuff. And so if you look at our room, it's a fairly big room. It's bigger than the view. The resolution is a little weird because it's scaled to my Windows phone, which is a bit of a shame that it's not iOS or Android, because if it was Android we could do stuff with haptic feedback, making the phone vibrate when you hit the keys, but Windows Phone isn't that awesome. Anyway, or at least not with GameMaker compatible stuff. So this little guy, if we go look at his code, working name, burstash, not an innuendo of any kind. Anyway, so this is it. This is left, right, up, down. Stuff happens. And a few things about limiting the room constraints. So basically, the easiest way to adapt this kind of game, which right now I was just playing with the keyboard to mobile, is to use virtual keys. So just take the left, right, up, down keys and map them right to the screen. And the way we do that is using this wonderful function called the virtual key add. So if we wanted to do something, we could say virtual key equals v key, oh no, sorry, add. And then the arguments for this function are a little different from some of the other stuff. A lot of the stuff in GameMaker, like if you're using the physics engine, usually you want to have the x coordinates be the center of whatever you're adding, but in this case, when you add a v key, it takes 5 arguments, and the first one is the actual coordinate of the key, so the xy coordinates of the key in space. So in this case, we'd be going for closer to the bottom of the room, but we'll get to the specific stuff later. So anyway, if I say, for instance, if I make a key with the coordinates of 32, 32, it's going to be its left upper anchor point in the room, and then the width and the height are in turn exactly what it sounds like. So if I make this key 128 pixels wide and 128 pixels wide, and then let's just say I make it a down key, that will add into the room a virtual key. So it's always good to comment the code. It's at 32 by 32, and it will be 128 pixels wide, 128 pixels tall. And so now if you want to, for debug purposes, if you want to be able to see this, you can say virtual key hide or show, sorry. And this lets you show the bounding box of the virtual key on screen. It's a little bit of an unwieldy function just because instead of doing like a semi-transparent outline, it gives you a solid white box and sort of blocks out the entire view. But for getting an idea of where in the room your key is, like for instance if your sprite and your key aren't lining up, it's useful. So now we can run this, and it should work. So, see, right there, there's our virtual key. Ah, that's an annoying sound. Anyway, freesound.org, everybody, it's a great place. So, if you look here, the key is at 32 pixels, by 32 pixels, and then it's 128 pixels tall, 128 pixels wide. So the actual, this coordinate is not at 128, 128. It's at 32 plus 128, 32 plus 128. So that's pretty simple. And if I pull out my mobile phone, I can show you the touchscreen in action, but we'll do that in a sec. Right now, we're going to work on positioning the actual D-pad and mapping that to everything. So let's take a look at the room editor. And over the Christmas holidays, I actually got a copy of Photoshop. So I was able to use that to make some on-the-fly sort of D-pad graphics. And if you look, we have our D-pad. Or a directional pad, I should say. But we'll call it a D-pad. So now if we plunk that at the bottom of the room, make sure it's in the view. Yep, it's at the lower left corner of the room. This is great, right? It's gonna draw perfectly. Right now it's just a dummy object. It doesn't do anything. But the problem with our setup right now is that if I move this way, you'll notice that it's anchored to within the view space. So we can just run away from it. It's not like the graphic user interface in the upper left with the number of candy I'm collecting. Like that travels with us. And the reason that is because it's drawn to something called the GUI layer. A few versions ago in GameMaker Studio, they added a new function called drawing to the GUI layer, and it's really useful because before, everything would get sent to this one draw event, and the draw event depends on where in the room the view is positioned. So if previously, if you wanted to draw things like health bars or heart counters, you would have to offset it using the view coordinates, which was a little tedious to do and not super convenient, and it was sort of glitchy. But then recently they added the draw GUI event, and so all that does is instead of drawing to wherever you are relative to the view coordinates, it just draws within the room space. That didn't make sense. Okay, I'm going to try saying that again. All it does is it treats the coordinates. It basically does all the view offsetting for you. So if this view is over here at 128, 128, it'll make 128 by 128 the 0, 0 coordinates for the view. Okay. So what we got to do is we got to take this dummy D-pad object, and we need to make sure that it's being drawn to the GUI layer and not to just the regular old room like all the other objects. And so the easiest way to do that is to actually make it stop being an object and treat it as just a sprite held within the control object. So if we go to the draw GUI event, let's actually make that a separate function. It can make, and always remember, comment, // it can explain your code function. Okay. It makes it way clearer for when you're looking back at it 6 months down the road, or for other people trying to figure out what your code does. So draw the D-pad. So we're just going to use a special function called drawSprite.ext or extended. And what we're going to do is we're going to take the sprite D-pad, which is the name of the sprite over here. Notice that the anchor point is in the upper left. It sort of matches where the virtual keys are anchored. And then we're going to set its image index to 0. Its sub-image. There's only one sub-image in the sprite. And then later on, we're going to store these in variables. But for right now, we're just going to sort of hard code this in, look for some magic numbers. When we create the dummy object, we want it sort of resting right on the edge of the room. So we can look at its x coordinates, and those would be, if you look right down here, 0 by 512. So dummy objects are useful for sort of getting a reference or mocking up what the UI will look like before you actually go and code it. Alright. When we're finally done, there's actually going to be a bit of a margin around the directional pad. But anyway, and then we want the scaling of the image to just be 1:1 aspect ratio. We don't want to rotate it at all. And then we want drawing color of white. That way it just comes out the way it looks in the sprite editor. And then we're going to give it an alpha value of 0.5. That's why we're using the draw sprite extended function, because if we were using the regular old, did I forget an argument? I think I forgot an argument. Oh no. Yeah, okay, sorry. Forgot the image index. Alright, the reason we're not using the regular draw sprite function is because it does everything this function does, but it doesn't let you toggle the alpha value. So, or change the drawing color, but that's less important for what we're doing. So now, if we run the game, you'll see that it shows up right there. And now, if we walk around, dang it, okay. If we walk around, it follows us. Great, now all we have to do is actually assign keys to it, which is where things get a little more difficult. Because, notice how I'm strafing diagonally? That's because I'm pressing down 2 keys at once. So when we make this directional pad, we have to figure out a way to preserve the sort of 8 directional movement I have. So that means, don't eat me, okay. That means these upper diagonal arrows, they need to be mapped to something. So we're going to use a sort of cheaty workaround way to do that. So now if we go up to the initializing the virtual key is, this virtual key is not that useful to us. We want to, A, it's in the wrong place, and B, it's blocking out the rest of the UI. So this is the really heavy meaty code. What we're going to do is, if I have Photoshop open, we're going to do something sort of like this. We're going to assign the left arrow key to a virtual key over here, the right arrow key to a virtual key over there, and the up and down to the top and bottom ones. And the genius, if I do say so myself, of this method is that where the keys overlap, it'll behave as if you're pressing down both the, for instance, the up and the left arrow keys at once, as if it was a physical keyboard, and this lets you preserve the diagonal strafing without having to go into weird fancy analog sticks. So what we got to do then is we need to make a bunch of overlapping virtual key tiles. And so we're just going to use 4 virtual keys, but because of the way we position them, we're going to have 8 directional movement. And there's a few drawbacks to this method, just because what ends up happening is that you'll notice that when I am actually playing with just the arrow keys, so the speed I'm traveling at when I'm just pressing one arrow key is noticeably slower than if I'm diagonally strafing. And this is because the combined vectors of what I'm doing, this is tying in a little bit of geometry. We're moving down in one direction and right in another direction. And in this case, the speed at which we're going is 8 pixels, and then another 8 pixels. So if you've taken any sort of physics class, actually the way we want to compute this is, that's the hard cosine way. We're going to do it the easy. Let's draw a line way. Okay. Now we've made a right triangle. If you have ever made a physics class, the way you calculate the new direction and strength of this vector is by drawing a diagonal line. And you'll notice that this is a 90-degree triangle with equal sides. So it's an isosceles 90-degree triangle. So using Pythagorean theorem, we know that 8 squared plus 8 squared equals c squared. And what it really comes out to is roughly, this is if we simplify this down, we call this 1 pixel by 1 pixel. This line will come out to about 1.41 pixels because it's the square root of 2. So when we're traveling diagonally, we're actually traveling at 40% greater speed than when we are when we're just doing individually either up, down, left, or right. For this game, it doesn't really matter. It doesn't impact the gameplay that much, but it does change the balance a little bit, encourages players to sort of cheat by strafing to get away from enemies. And if you want to get around this, you have to use a more smarter input method. But that's for a different tutorial. And actually, next video we're going to be going over analog sticks, like Xbox 360 analog sticks, and emulating those on the screen. And that's one solution to avoiding the speed increase when you have two vectors going at each other. Anyway, that was a bit of a tangent change. All right, so anyway, now that we know what we're going to do, we have to code in our virtual keys around where they're going to show up. So we need a virtual key over here, a virtual key over here. Actually, they're going to be more like rectangles. So rectangle here, rectangle here, rectangle here, rectangle here. And when I was doing this initially and debugging things, I found that when the way this works best is when you have one rectangle that goes about a third of the way across, another rectangle that goes about a third of the way across. So this space in here is left empty, and that way the overlapping space is about a square. Let's dive in and start coding this. So the first thing we're going to do is to simplify our life. We're going to, well, actually, we'll simplify our life later and discover how not simplifying our life makes our code look really, really messy. So we'll start by partition this off, called the debug section. Again, comment, comment, comment. So what we want to do is make 4 virtual keys. And the way we do that is we're just going to call them V key up. Let's actually make that V key up. Okay. And then we're just going to copy that 4 times. Wait. There's the... In practice, I start with left, up, right, down. Okay. That way the sort of backwards coordinates are together and the forwards coordinates are also together. Because when you're going left, you're subtracting values. When you're going up, you're subtracting values. But right and down are adding values. So now we have to figure out where in the room we're going to position our sprite. So if we look back at drawing the DPad, you see we chose 0 by 512. And that works pretty well. Although, like especially in Windows phones, there's okay, so you'll notice that on most Windows phones there's 3 buttons on the side, and if you imagine someone holding the phone in landscape position, that can be problematic if the UI buttons are literally right next to the search or home buttons, because if the user accidentally touches those, then the app will minimize itself and totally disrupt the gameplay flow. So at least in my opinion, I think it's better if you have a little bit of a margin between where the arrows lie and where the edge of the screen is. So in our case, it's going to be a pretty small margin of only about 16 pixels. So let's start putting that in. It's going to be at 16 pixels by whatever the room width is plus 16 pixels. So we're going to call the function display get GUI height. And what that tells us is it tells us not how tall our room is, but how tall the display we're rendering to is. And then from there, we're going to want to subtract our image height. So we want to get the height of the DPad sprite, which in this case is about 256 pixels. And then we're going to add to that, or subtract further from that, another 16 pixels. And then we need to make our virtual keys, we need to define their width and height. So from there, what we're going to say is we need to get the width of our directional pad. Which is also, because it's a square sprite, it's 512 pixels. And because this is our left key, we only want 1/3 of that width. And then from there, we need to get the height, which in this case is just the full height of the D-pad. Now, that's one key. I do have my font a little big, so the line looks longer than it really is, but still, that's a really long line of code, and if you notice, we're calling 1, 2, 3, 4 functions within one other function, which, by just common sense, that's pretty darn slow, especially if we're calling that 4 more times for 3 more keys. So we need to find a way to optimize that. And the way to optimize that is to start putting things into variables. In fact, you want to put as many things into variables as possible. And we're going to start with the directional pad coordinates. Although before we do that, actually, just to make sure everything's running correctly, we're going to show this key on screen. Well, we also typed the wrong keyboard key. All right, that's getting cut out. And look at how we accidentally left the dummy object inside of the room. But anyways, now, if you look, our key is showing up right here, approximately where our arrows are. And it doesn't have to line up perfectly, because when the user is actually touching the phone screen, they're not really going to be able to tell what they're doing. This is sort of just a rough draft of something that if I actually turned it into a game, I would clean up. But anyway, so this is 1/3 of the total image, and then the entire height. And if I was using this on a phone and I clicked it, it would make me go left. We'll get around to testing that in just a second. But now, to streamline, because this is bad coding, really bad coding. And so we're going to go in and start making variables. So we're going to start with the directional pad coordinates, just so that we don't have to memorize that we're rendering at 16 and then whatever the heck else it is. So we're going to call this the D-pad X coordinate. We're going to make that 16, and we're going to make the D-pad Y coordinate, and we're going to make that the display. Actually, if you just look right here, get GUI height minus the sprite width, blah 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 blah. We'll take that and put that right there. Okay. And so what this function does is it gives you the display height, and then you take away the sprite height, and then you take away another margin. Actually, there's a way we can streamline this even further. We can take out this chunk right here, replace it with height, and then up here make a section called local bars. And now we have the width and height of the sprite stored. And instead of calling the, for instance, the height function 3 or 4 times within one function, we have it stored as a value, and that saves on CPU time. So little code optimizations are always useful. And now we're going to go through and start coding in the other virtual keys, now that that's taken care of. So another thing we want to do, just as a passing thought, if any other instances ever want to reference these virtual keys, it's easier to type, make them a global variable than to have to reference object control. So that's just more good practice, universal reference for the virtual keyboard keys. Now we're going to go through and we're going to make sure that the up, right, and down keys all also render correctly. And so we're going to take this sort of one step at a time And for right now, I'm going to comment out these lines. And this way we can get an idea of just, this is the left bar, this is the right bar. These two other bars won't be rendered right now. So we go over to the right one. And actually, before we do that, we want to replace these values with our new variables. So we're going to replace 16 with DPad X and this long thing here with just DPad Y. And already the function is looking easier to read. So then here we can just take this, replace it with width, replace this with height. And this looks way more readable and understandable and less cluttered and faster and more optimized than what we had before. So now we'll just copy that, or at least this part of it, and plunk it over here. So now there's a few modifications we have to make because now we have to make this, the coordinate of this show up at the other end of the block. So if you remember, we're splitting up our keyboard into thirds, which means that we need to add to the initial x coordinate 2/3 of the width. And we'll just stick that in parentheses. So if you're having trouble visualizing that, and you probably are, now if you notice, we're going to have our virtual keys, the left one over here, oops, ignore that, the right one over here. And so this one has just the coordinates of x and y. But this one, if you look, this is 1/3, this is 2/3, this is 3/3. But this is what's 1/3. These lines right here. So to find the anchor point of this rectangle, we need to add 2/3 of the sprite width to the x coordinate. Which sounds like a mouthful, but once you see it in action, it'll make sense. Alright, so we have the x coordinate plus the width divided by 3, but now we have to also multiply it by 2. And then that ensures that we are working. Actually, we can stick this outside the parentheses. PEMDAS, order of operations, ensures that this will run first before the DPad X. Alright, and then the DPad Y, we can keep that the same because if you notice in this picture, they have the same Y coordinates, just different X coordinates, and then the width we want to keep the same, the height we want to keep the same, and we want to change the key we're assigning, and we're going to make it the right key. So here it's going to be virtual key show, V key, right. And actually we need to assign globals in front of this, otherwise it's going to crash. Okay, so now we run to make sure it works. Now if you notice, it's kind of, the positioning is screwed up, which is not good. But we will fix that later, I hope. Now, the last two keys, and I'll try to make this faster since now we have the general idea of what's going on. So the up and down keys are basically the same thing as the left and right keys, except that the x coordinates become the y coordinates, and the y coordinates become the x coordinates. So it's sort of like writing an inverse function for all you algebra people out there. All right. So now instead of width divided by 3, we're going to do height divided by 3. And then for the down key, okay, that looks about right. So now, see how the height and the width are interchangeable. We're going to reveal these keys and hide the other ones. Now we're all set. So now we look, and sure enough, it's 1/3 over here, 1/3 over there. And if we draw those all at once, this is where I wish they had alpha values for the virtual key debug function, but they don't. You'll see that they overlap to sort of make a 3x3 square with a hole in the middle. And perfect. Now the only problem is that our sprite is now off. So it was off by probably roughly 16 pixels, and so all we have to do is go into the draw DPad function, and instead of using these magic numbers we randomly pulled out of nowhere, we replace them with what was defined in the create event with DPad X and DPad Y. That's another reason variables are nice, because if you change the value, you don't have to change it in 500 places. If it's a number that's referenced 500 times, the value just updates itself throughout all of the functions, which makes life much, much easier. You'll notice that the directional pad and all of the boxes line up pretty much right where they should be. The reason there's a little bit of overlap is that because I drew them by hand, they weren't that carefully done. But anyway, so that's working. And so now I'm going to show you what this looks like running on the actual cell phone. All right. Now we run it. Oh, there we go, flip. So now it's working pretty well. Things up, caught on a bush. Not a problem. Now you'll notice though, the diagonal motion is working, everything's fine. The only problem is if I put my finger out, oh, that's a little touchy, isn't it? So if I'm going down, I want to go, oh no, I'm stuck. And it, the player just sort of randomly stops. Although it's not really random, it's just that they think it's random. So you want to allow that extra margin. Alright, now you may have noticed that when we were running this on the cell phone, although the bounding box of the virtual keys is really close and tight to the directional pad, and that's probably ideal if you were using a physical controller, it's not so good on a mobile phone because you might have noticed my finger a lot of times slipped outside of the bounds of the arrows, and then the character would just stop moving. So what I got around to thinking is that it would probably be a good idea to put in a sort of invisible margin for the virtual keys around the actual D-pad that's rendered on screen, just so that users have a little bit of leeway when they're moving around. They don't get frustrated when suddenly they stop moving when they think they're still pressing the buttons, but they aren't. So that means we need to make another variable, and it's called margin. And we want to probably make this after the D-pad coordinates. Yeah. So we're going to call this margin. We're going to make it we're going to start out not so big. We're just going to make it initially a margin of 16 pixels. And that way you'll see that the D-pad is filled to the edge of the screen, which is also good in case the person's hand slips off the phone. To make life easier, we also need to make a new set of x coordinates. And called just, they're dumb variable names, not actually, it probably should have been something more like modified x or whatever, but for right now it works. Sort of shoddy code. So anyway, D-pad x minus the margin, and over here D-pad y minus the margin. What this does is actually we don't need to, none of these variables we really need to store for the duration of the instance's life cycle. These functions, these variables, the only variables we need for later on are this one and possibly this one, just because they're called from the draw function. But otherwise, yeah, we're all set. So from there on out, let me explain the reasoning behind this. So when we're adding on a margin, alright, so we have our rectangle, and it's divided into thirds, but that's not really so important. What we want is, just in case the player's finger strays slightly outside of this rectangle, we want to give them a little bit of room for error. So we're going to put in a margin. And let's say, although this isn't what it really is, we'll say it's a margin of 16 pixels like what we're working with now. That means that this upper left coordinate for the margin is actually, this box is x coordinates subtracted with 16 pixels subtracted. I can't talk today, I'm sorry. Okay, so it looks something like that. And on the flip side, this corner, the width, the distance from here to here, is actually, this is the original width. Let's call this W. It's the width with another 16 pixels on either side. So it's the width, the new width of the triangle is the old width plus 2 times the margin. So what that comes out to in our case is if we have a width of 256 pixels, we end up with a width more like 200, oh god, math, brain fart, 288, I think. And for total width, that might be wrong, but whatever. So in code, we have to define the upper x coordinate for the virtual key, and then we also have to make the new width with the extra width added. Diagrams always help for explaining things. So let's pop back over into GameMaker. For now, you might say, why not just append the 2 times the margin to this function? It's because depending on where you're using it in the virtual keys, it actually, the value differs for the width and the height that you want to use. So we're going to leave those the way they are. But now, all right, we're going to do stuff with the margin. So this is where things are going to start to look messy, unfortunately. So we're going to replace this DPad X with XX, actually everywhere. Here's another trick of programming magic. You just find DPad X, replace with DPad Y. Okay, replace them with the variable XX. You can get to this window by hitting Control F on your keyboard. And then we're going to do the same thing for all of the Y coordinates. Just simplified our life. So now we go over here. You'll notice that this is now screwed up. The one place we actually needed the DPad X and the DPad Y is replaced, but we can just write that back in. So, I don't know how to close this window. It's on one of the GameMaker's user interface is not very intuitive. Okay. From there, we need to start plugging in variables. So this is still fine. This is all fine and dandy. Although we do need to now add to our margins. So we just add here, add the margin. And here we add 2 times the margin. Now we'll go here to see if we can make sense of why that is. So if you look, this is where our new coordinate is. The way we have it now, if you add in the extra third, you're just going to end up at the original coordinate. You're not going to be actually overlapping the buttons. So in addition to having the original width, you have to add on the margin to get back to here. It's sort of like uniform scaling from a center point. And the same thing goes from the height. So what it would be is we now need to go all the way down here. So if you notice, again, we're adding the margin here and subtracting the margin here. So we have to do this plus 2 times the margin. And the same thing goes for the width and the height of all the other columns. Okay, so this part you can, I'll just rush through it, and hopefully it'll make sense. Okay, that's done now. Great. Now we're just going to run it to make sure there are no mistakes. There are probably tons of mistakes because nothing ever works on the first run through, but we'll see. Yep, great. We didn't define, oh yep, and guess why that is, because up here, we forgot to rename this. find and replace is powerful, but also dangerous. Okay, run again. Now, if you notice, except for like 1 pixel of deviance, I'm just trying to get away from these guys. Okay, right there, you can see there's a little bit of overlap, but that's just a rounding error. So now the 16 pixel margin extends. Previously, the white squares went out to here, now it goes out to here. And now we have a larger margin. Although, through my own screwing around with it, what I sort of found out is that it's more convenient when you can just trail your finger out a long ways. So I made the margin pretty big. It doesn't hurt. It doesn't really change the way the controls work. It just adds even more room for error, which the player won't usually use, but it's convenient to have. So if we make the margin 128 pixels, you'll see now it's still centered on the D-pad, but it's now super large. And that's just good because if you have really big fingers, I hate that sound. If you have really big fingers, you can go out a long ways and still be controlling the character. So I'll show this in practice on the mobile phone so you can tell there's not a ton of difference, but it's the little things that make or break games. Okay, so here we go. Yeah. Yeah. Alright, this is much easier to play when you're not looking through the camera. Well, the reason I'm getting stuck on bushes is not because of the controls, it's just the collision code is pretty faulty. Oh. So here's that margin I talked about earlier. If you notice the distance I can travel, watch how far I'm sliding my thumb once I get away from these guys. Oh no! So I can slide my thumb this far out before. See how far I'm touching? It's a nice bit of leeway, just so the controls aren't super picky. Okay, so that's really about it. I'm gonna show very soon how you can apply this to using state machines, but basically all this does, now if you'll notice, our what used to be our nice clean code is now pretty darn ugly, but it's better than it could be with lots of different calls. Yep, so that's it. I will put in total, this is actually not that hard to implement. It was this one script followed by this one other script. So I'll put those 2 scripts in the description. I'll link to a Dropbox link for them in the description, and I'll also have this, and maybe also the example project, but I'm not sure yet because it's kind of big. But next time we'll get around to seeing how you can tie the keys to moving characters around in interesting ways, and also probably explore some alternative touch-based navigation methods, like using an on-screen analog stick or maybe tilting the phone to get the player to move. Thank you for watching, and make sure you like, favorite, comment, share, and subscribe, even though it's a tutorial video, so you probably won't. But anyway, it would be great. So thanks. Bye.